Hello, good morning, good afternoon. I'm Justin Hominski, and today I'm going to be presenting my system stability GUI, or my GUI, in MATLAB. This is for my computer tools lab with Dr. Chung. Yeah, so what's our objective? So we essentially want to create a GUI, which is an interface that allows a user to interact with any sort of system they may have, whether that be, anything. If it's a transfer function, numerator, denominator, anything. This GUI has the ability to create bode plots, like phase margin, step response, and a lot of other information that we use in the MATLAB library to be able to characterize these functions. So, some background. We have stability analysis, why MATLAB, an integration using GUI, and a custom bode plot, as per request by our professor. So we want to ensure predictable, safe, and reliable system performance. Why MATLAB? The reason I chose MATLAB, it gives a really easy interface in terms of visuals. It's very widely used, and creating an application, there's a lot of resources online to kind of help guide through that. Sorry. It's also very beginner friendly. There's a lot of tools, and then the custom bode plot was the only thing that was a little bit of a challenge due to the fact that they do have a bode plot in MATLAB library, but creating it from scratch is a little bit different. So here's the layout of my system analysis tool. We have a custom bode plot, step response, root locus, system information, gain, and phase margin. So, and I also have a input box where the script will take in the input in the numerator and in the denominator, store it in an array, and it will plop out the custom bode plot, step response, root locus, everything like that. And you can have a frequency range. It's not really something you touch. It doesn't really matter in terms of it does matter, but in terms of just understanding or looking at sort of a graph, you can choose a general frequency range. And then you can run the analysis and export as a picture, a PNG, so that you can upload it wherever. So here are some of the points I have. The system info panel, user-friendly design, just makes it easy to kind of, just plug in your function and get a response back. We have all the right areas here. Yeah, I already explained all this. So the core functionalities, I've already explained this as well, but we have the root locus, step response, detailed system info, and we can do a manual bode plot generation, and we'll see what the axes are for the bode plot, so we know it right. So creating this custom bode plot, we're going to have the magnitude, the phase, and those are also going to have to, the magnitude is going to be in decibels. For each of the frequencies, it's evaluated as a h of j omega, and it'll evaluate the polynomial of the numerator in j omega, whichever j omega we choose. Each iteration will run through a loop, and then also our phase and degree, so it'll take it and multiply by 180 over pi. So we use log space to generate the frequency in a logarithmic scale. That's just how the bode plot is. It uses a log space for one of the axes, and y-axis plot left would be the magnitude, the y-axis, and the right y-axis would be the phase. So it's a plot against the phase and the magnitude. So this, why this matters, it kind of just helps me out in a way to understand more about why or what the bode function actually does, and not just use bode function and just give you an output. So it kind of reinforces my concepts and transfer function evaluation. Alrighty, so here's an example that I did, where we have the transfer function as s squared plus 3s plus 5. In the denominator, we have s squared plus 2s plus 3. And with the frequency from 0 to 1,000. Essentially, here I have the custom bode plot that shows the magnitude and phase, And you can see that in decibels, and you can also see the logarithmic scale at the bottom, gain and phase margin, so how much kind of it has before it becoming unstable. You can see the root locus, stability control design, that's what it's mainly used for. And the step response to show its kind of settling behavior. You can see how it kind of plateaus a little bit there. And then a summary at the bottom of like peak time. You can see poles, zeros, overshoot, kind of how far it overshoots, the settling time, how long it takes to settle, peak time, rise time. So this is all just, general things that you want to know about a sort of system and how it responds or how it reacts. So if you have an input and how that's going to react to the system as well, and maybe in the future I can add that as well. And then the gain margin and phase margin as well. So, yep. Anyways, the challenges and solutions. So I think challenge number one was doing a manual bode plot, and looking back at the lecture that we had helped a lot in terms of, okay, what do we need to create this function? We need, log space. We need to evaluate that sort of h of j omega. So I'll go back to my code and show you kind of how I did that. But also sizing, the positioning. I didn't use the app creator. I kind of created everything myself, so I'd have to generate the background for it. I needed like the position right, I needed it to fit in the figure, I needed the window to be big enough, I needed the buttons to be functional. So all those little things I had to go through that took me a while to kind of figure out how to do. And just displaying multi-line system info like one at a time so that it would display properly, because before it was getting cut off or it was too far off to the right of the page. And using certain functions, I was able to display that text evenly. I learned a lot about programming in terms of MATLAB, analysis techniques, application control theory, and debugging, testing, experience design. And yes, here's the demo link. It will be here. So I'm actually doing it, and then I'll post the link into there. And the conclusion will recap. This is my GUI. The tool is practical, user-friendly, and maybe I'll add a Nyquist plot or support for memo systems. So, this tool has the ability to be able to analyze most systems, but maybe want to make it more diverse and open up to different systems and add more plots or just anything in general, like I said before. But yeah, thank you so much. Have a great one.